right, ladies and gentlemen, today's objective is to find the mean for a given set of data. We're also going to be able to add and divide accurately with whole numbers, fractions, and decimals. So a quick review of those different skills as well. The mean is a central measure of tendency, and you may have heard of mean, median, and mode. The mean is the average. The median is the middle. And notice when we say mean, median, mode, median is usually the middle word or term. The mode starts with MO, and it's the most often occurring. Most also starts with MO. But today's main focus is the mean, so let's go ahead and look at the definition. The mean or average is a number that expresses the central value for a set of data. It is calculated by dividing the sum of the numbers in the set by the number of quantities or data pieces. So we have an example right here. And in order to calculate the mean, the first thing that we need to do is find the sum, which means that we're going to add all of these values together. So first we're going to go ahead and put down, let's see here, we're going to have our sum by adding 8 plus 10 plus 14 plus 6 plus 6 plus 7 plus 12. And we're going to end up dividing this by the number of quantities, but when adding, it's easy if we use our commutative and associative properties to add our compatible values together first. So in this case, like 8 plus 12, we get a nice round 20. 14 plus 6, again, we get a nice even value such as 20. And when we add in the 10 here, those are easy numbers to work with. And finally, 6 plus 7 is 13. So using these properties will allow me to add in any order I want, and I can kind of find numbers that work well together to make this process a little faster. When we add these values together, we end up with a sum of 63. Now we're going to have to divide that by the number of quantities. So we have 1, 2, 3, 4, 5, 6, 7. So we're going to take 63 divided by 7, and we get the mean is equal to 9. So again, add the numbers together, divide by the number of pieces of data. Let's practice. Go ahead and pause the screen and see if you can find the mean for this set of data. If you forgot about how to add fractions, remember that you want to group the common denominators together. We need a common denominator when adding fractions. Okay, let's see how you did. First of all, if we group all of the fourths together, we have these three values, and we can add them together pretty quickly. When I add 3/4 and 1 1/4, I get 2 plus 1 more fourth. So I have a value of 2 1/4 as this sum. And then I'm going to group up my eighths. So I have 3/8 and 7/8. And when I add these values together, remember you add the numerators and the denominator stays the same. So 7 plus 3 is 10. And when we convert this into a mixed number, we get 1 2/8, which is actually the same as 1 1/4. And then we're going to go ahead and move on to 1/6 plus 1/3. And in this case, we want to have a common denominator. So since the 1/3 does not have a common denominator, I'm going to convert that. And 1/3 is actually equal to 2/6. So if I replace this 1/3 and I put 2/6 up here, which is an equivalent fraction. Then we can add the numerators, and the denominators will stay the same. So 1 plus 2 is equal to 3, and the denominator stays the same, 3/6, which is actually the same as 1/2. And finally, I'm going to go ahead and add my other 1/2, and we get 1/2 when we add those values together. So now my different values that I have 1 plus 1 1/4, which is 2 1/4, plus 2 1/4 is equal to 4 1/2. 4 1/2. And what I'm going to do now is I'm going to take that 4 1/2 divided by the number of pieces of data. So I need to go ahead and throw these numbers all back in the set and see how many pieces of data we actually have. And we'll throw this back here, here, and here. And notice I left off the 2/6 because that was an equivalent fraction. I'm just going to erase all of this other stuff, since we already have our sum of 4 1/2, and we're going to delete this value right here real quickly. So I'm going to take my total or sum, 4 1/2, and divide that by 8. When dividing with fractions or mixed numbers, we have to convert into an improper fraction first. So we take 4 times 2 is 8, plus 1 is 9 over 2. And we need to do multiply by the reciprocal. So instead of dividing by 8, you're actually going to multiply by the reciprocal of 8, which is 1/8. Look for any cross canceling, since the only common factors between the numerator and denominator are 1, or is 1. Then we simply multiply. 9 times 1 is 9. 8 times 2 is 16. And my mean or average here would actually be 9/16. Is that somewhere in the middle? Yes, it is. So that's a reasonable answer, and that is the correct answer. Moving on to the next problem. Find the mean for this set. Now we have decimals involved. So again, pause the screen, add them together. Don't forget, when adding decimals, we need to line up the place values and line those decimals up as well. And then you're going to divide by the number of pieces of data in the set. So in this case, we have 2, 3, 4, 5 pieces of data. Okay, let's see how you did. When you added all these values together, hopefully you lined the decimals up. I would have put the numbers together just like this and line those decimals up neatly, and then added all of those different values together. When we add the values, it's always helpful to add the decimal if necessary and annex some of these zeros in. But you should have come up with something along the lines of, if I put that 1 there, 1 here, and we get oh, there would have been a 2 right here. So we get 41, and bring that decimal straight down, 41.50, which is the same as 41.5. Now we want to take that sum and divide by the number of pieces of data, which is 5. Okay, don't forget the first number is actually our dividend, and the dividend goes in the box. Okay, the second number, what you're dividing by, is our divisor, and it goes outside the box. And now we're ready to divide. So 5 does not go into 4. I like to put a little X here just to keep my place values lined up. 5 goes into 40 8 times, which is 40. Or it goes into 41 8 times, I should say. And when we subtract, I have 1 left over. I'm going to bring that 5 down. and 5 goes into 15 3 times, and your decimal will go straight up in your answer. 3 times 5 is 15, and we have a terminating decimal, an exact value. The mean is 8.3, or 8 and 3/10. Moving on. The last page, it says find the mean for this set of data. We're not actually going to find the mean, but you'll notice one of the numbers changed. Instead of 5.03 or 5 3/100, I now have 50 3/10. This is called an outlier. It is a data point that is significantly far away from other data points in a set of data. So notice all the others are right around 10, 11. Some are a little bit lower than 10. We found on the previous page that our previous average was 8 3/10. And now we have this much larger value here. Well, we want to think about this. How will the outlier affect the mean? Since that number is much higher, that's right. It will increase the overall sum, which is going to make the overall mean increase as well. So if our outlier is a much higher value, it's going to increase the mean. If it's a much lower value, it will decrease the mean. Well, I hope this helped you out. See ya.